Hello everyone, today we are beginning section 2 of Unit 8. Unit 8 is all about triangle similarity, and section 2 is where we begin to prove that two triangles are similar. In order to do so, we have three new theorems that we're going to be using, and we'll go through these here. So before we had triangle congruent shortcuts, side, 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 angle, angle, side, and angle, side, angle. When we're doing triangle similarity, we have three of them, and it is angle, angle, side, 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 and side, angle, side. And these are triangle similarity theorems. So starting with angle, angle. For angle, angle, if two angles of one triangle are congruent to two angles of a second triangle, then the triangles are similar. In a picture, what that looks like is if we have triangle ABC and triangle DEF, where angle A and angle D are congruent, and angle C and angle F are congruent, then we have two sets of angles between our triangles that are corresponding and congruent, and therefore our triangles are congruent. So if you can show that two sets of corresponding angles are congruent, then your triangles are similar. Not congruent, but similar. Alright, next we have side, 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 which says if the measures of two corresponding sides of two triangles are proportional, then the triangles are similar. So in a picture, what that looks like is right here. We have triangle A and triangle B, where triangle A has 4, 5, 6, and B has 8, 10, and 12. And these are all on a similarity ratio or a scale factor from A to B of 1 to 2. 4 times 2 is 8, 6 times 2 is 12, 5 times 2 is 10. Therefore, because all sets of corresponding sides are on the same scale factor or are proportional, then triangle A is similar to triangle B. And then third, we have the side angle side theorem, which says if the measures of two sets of corresponding sides of two triangles are proportional and their shared corresponding angles are congruent, then the triangles are similar. So in a picture, what that means is that we have triangle LMN, triangle OPQ, and we need two sides that are corresponding and proportional, 10 to 30, 10 to 30, it's the same, and their angle, their shared angle, the angle between them, has to be congruent. So if angle M is congruent to angle P, and LM is proportional to LM to OP is proportional, and MN and LM to OP has the same scale factor of MN to PQ, which it does. It's a scale factor of 1 to 3, and our angles are congruent, then our triangles are similar. So we have angle, angle, side, 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 angle, side. Now we're going to take those three things and we're going to start doing some triangle similarity proofs using these three theorems. So let's take a look at our first one. This is example 1. We want to prove that these two triangles are similar. So I need to think about angle, angle, side, 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 angle, side, and what do I know in this image, and which of those three things can I use? So when I first look at this image, I notice that I have these angle markings. They are both 90-degree angles. It's a right angle marking, so therefore we have one set of congruent angles. So we definitely can be using an angle. So we're either looking at side angle side or angle angle. If I'm looking at this picture, I'm noticing that there is nothing to do with any sides that are marked at all. So using side angle side is not an option. So I have to use angle angle. And since I'm given one, I have to look to see about the relation between the triangles in order to find the other angle, which in this case, we have vertical angles right here. So I can use angle angle because I know of two sets of corresponding angles that are congruent. So I'm going to go ahead and start with my given statement. That's the piece that's already given to me. I have angle A is congruent to angle D because it's given. It's given with the angle markings. Next, I already acknowledged that I have vertical angles here. So I'm going to draw that into my picture that these are congruent. And in my proof, I'm going to say that angle BCA, making sure that the vertex is in the center, is congruent to angle ECA. And we are able to say that, and we know that those are congruent by the vertical angles theorem. All right. And by the way, I pre-populated these charts in my notes here, but yours does not have that, so you'll need to add it in. And I added some rows, and we may need to add some extra as we go, or we may not use all of them. It just kind of depends. I just use the same one for every single thing. And we're getting to the point now where we previously had been using charts and you've been given boxes and you had to fill it in from there. And it will still be like that on your mastery checks, but in your practice questions and in your notes, we're not having those because you do need to start getting to the point where you aren't relying on the number of boxes for telling you exactly how big or long your proof should be. All right, so I've shown that I have one set of corresponding angles, or congruent angles, and I have a second set. So I can conclude my proof here. I can say that our triangles are similar. So triangle ABC is similar to triangle DEC because of the angle-angle triangle similarity theorem. All right, there's my whole proof. So this is 3 lines. I only needed these 3 spaces. All right, let's take a look at another example. Example 2 says prove that these 2 triangles are similar. So I'm going to zoom in on these triangles here. I have 8 to 20, 4 to 10, 6 to 15, and I need to see if I can do anything with those side lengths because I don't have any information about angles at all. So angle is off the table, side angle side is off the table because we don't know anything about angles. So we have to use side. So I'm going to start by checking what these proportions are. So I have 8 to 20, which is simplified to 4 to 10. And then I have 4 to 10 already. And both of those can be simplified one step further to 2 to 5. And then I have 6 to 15. If I divide both of those things by 3, that gives me 2 to 5 as well. So I have the same similarity ratio for all of these sides, and I'm actually going to have to use that information in my proof. So the first thing I'm going to do in my proof, that first line, I'm going to take the segment names and put them in place of our original numbers in our fraction. So instead of 8, I have KL, and instead of 20, I have NP. So I have KL over NP is equal to 2/5. I have JL and OP. So I have JL over OP is also equal to 2/5. And I have JK over ON also equal to 2/5. JK over ON is equal to 2/5. And so I am allowed to do that by the division property. So I'm acknowledging the work that I already did, and now I can actually use that in my proof using the division property. All right, next, because all of those things have the same value, their simplified form of the ratio is the same, I can take that and I can use that to say that all of those things are congruent. So I have that KL is over NP is equal to JL over OP, which is equal to JK over ON. And all that together is really using the transitive property. You're saying that they all have the same value, so those things are all equivalent to each other. So that is the transitive property. All right, because all three sets of corresponding sides have the same value, they are congruent, I can then say that my triangles are similar using the side-side-side theorem. So I have triangle JKL is similar to triangle ONP using the side-side-side triangle similarity theorem. All right, now we're going to take a look at example 3, which says that, again, prove the two triangles are similar. So I'm going to look at these triangles here, and I am, again, going through my checklist. Is it angle, angle, side, angle, side, 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 side? Well, if I'm looking at these pictures, I do have markings for two sets of sides. So side, angle, side is a possibility, but side, side, side is not, because the third sides have nothing on them. So now I'm thinking about angle, angle. I know some information about these angles, but I don't know anything about any of the other angles, so I'm stuck with side, angle, side. So I'm going to start with checking with my side lengths for a similarity ratio. So I have, when we're looking at triangles like this, the similar side lengths are going to be on the same line. So I have 18 to 27, and I have 16 to 24, and that's the ratio that we're going to be looking for. So I have 18 over 27, which is equal to, if we divide both of those things by 9, that gives me 2 over 3. And then I have 16 over 24, and if I divide both of those things by 8, that gives me 2 over 3 as well. So we do have two sets of corresponding sides that have the same similarity ratio, and we know that the angles are vertical angles. So those are the three pieces of information that I need to use to solve this proof. So I'm going to once again start by acknowledging the division of my side lengths to get that ratio. So I have HJ over JL for my first one. In place of 18, I have HJ over, in place of 27, JL. That's equal to 2/3. And I have GJ over JK for 16 over 24, and that is also equal to 2/3. And the reason why I'm allowed to do that is because of the division property. All right, next, because they have the same value, I'm going to acknowledge that those two pieces, those two segment proportions are equal. So I have HJ over JL is equal to GJ over JK, and again, that is by the transitive property, because I have two equations that have the same value, so those two pieces must also be equal to each other. I acknowledged in the picture earlier that I have these vertical angles right in the center, so my next line of my proof is going to be acknowledging that these two angles are vertical and are congruent. So HJG is congruent to angle KJL. Angle HJG is congruent to angle KJL because of the vertical angles theorem. All right, since I have now shown that I have two sets of similar proportional sides, and I have one angle, their shared angle, that is congruent, I can then say that triangle HJG is similar to triangle KJL by the side angle side triangle similarity theorem. All right, example 4. Example 4 is a little different because it asks us to find a length after we've proven the triangles are similar. So the whole point of this is that if you can prove that triangles are similar, then you can in fact solve for those missing sides. So we're going to go ahead and start with looking for our triangle similarity, and if they are similar, then we will find our side length. If they're not similar, then there's nothing we can do. So starting with this image, I'm looking for things that I notice. And the very first thing that I'm seeing is that I have these arrows on these triangles, on these sides. So I have on FH, I have an angle, I have an arrow, and on JK, I have an arrow. And those tell me that JK and FH are parallel. So that's my given information here. JK is parallel to FH, and that is given. The markings are what give it to us. All right. Since I have parallel lines cut by a transversal, then that means that I have alternate interior angles. So I have angle J will be congruent to angle H, and angle K will be congruent to angle F. And that's all the information we need right there, and I can even put those in one line. Your other option is to use one of those angles, and then we have vertical angles here. So we actually know all three sides, and I will draw that out on here, but we don't need to use all three in our proof. You only need to use two. So I'm going to keep this simple and go with the alternate interior angles for both pieces so that I can put this all in one line. So I have angle J is congruent to angle H, and angle K is congruent to angle F. And if you would like to put this in two lines, you totally can. And those are congruent because they are alternate interior angles. The alternate interior angles theorem. All right. Since I've shown that I have two sets of congruent angles, corresponding angles in these triangles, then I can say that triangle JGK is similar to triangle FGH by the angle-angle triangle similarity theorem. Since these triangles are in fact similar, then I can solve for that missing side length of GK. So I'm going to switch colors here, and let's solve for our missing side. We have a couple options. We can use we have a couple different options on how we can solve, but I'm going to use the cross products. So I have 8, which is corresponding to 12 for GH, and I'll have my GK corresponding to 11 here. So 8 is to 12 as our unknown side of GK is to 11. I'm going to multiply across, solving for my cross products. So I have 12 GK is equal to 8 times 11, which is 88. I'm going to divide out the 12 on both sides, which means that GK is approximately equal to 7.3. So I can say, and there's no units here, so that's just what we're going to leave that as. So GK is about 7.3, which makes sense because it should be a little less than 8 because 11 is a little less than 12. All right. On the next page, I'm not going to go through all of these examples. I will link some separate videos for each of them so that you can watch on your own time if needed, but I will talk about how we need to figure out which theorem to use here. And so we're still with angle, angle, side, 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 or side, angle, side. And if we look at this image, to prove it, we don't have enough information with the sides, but what we do know is that we have these angles that are marked. So I for sure have one angle, so side, angle, side is a possibility. But for side, angle, side to happen, we would have to have RS and the full length of RT, because this bigger triangle is using RT. And that's not enough information because we don't know what this length is or the whole length. But we do have a second set of angles that are congruent. And this is where the reflexive property kicks in again. We have angle R, we have to say that angle R is congruent to itself because R is in both triangles. And that's what your proof would look like. Angle, angle, because you have one given and one is reflexive. Example 6 is the exact same type of format. We have one angle that's given to us, and then we have one angle, angle C, that is in both triangles. All right, and then example 7 here. So I have proof that the two triangles are similar. So I have that FE is 143. I have RE is 91. I know SR is 44. I know FD is 88. And SD is 56. So that's a lot of good, helpful information, but it doesn't tell me enough to know about side lengths for my sides without doing a little bit of solving first. So I need to figure out what the lengths of FR and FS are in order to use the side lengths. So I have 143 minus 91. That'll give me my first piece, 143. 143 minus 91, and that gives me 52 for this side here. So FR, this length, is 52. All right, and then I have 88 minus 56, which gives me 32. So the length from F to S must be 32. All right, so those are my missing side lengths. I have those now. Now I need to go through and prove my triangles are similar. And I can do that using side angle side on this one. So I know that F is in both triangles, that's reflexive, so I have that angle for both pieces. And then I have FR in the full length of FE, and I have FS in the full length of FD. So I'm going to start with checking to see that my side lengths are actually proportional. So I have 52 over 143 that we need to check. 52 over 143, which is equal to 4 over 11 when you simplify that. And then I also need to check for 32 over 88, which is FS over FD. 32 over 88 also simplifies down to 4/11ths. So we are able to prove this. We have two sets of proportional sides. So in my proof, I'm going to start by putting my division statements in. So that was FR for 52 over FE for the 143, and that was equal to 4 over 11. And then I had FS in place of 32, and I had FD in place of 88, and that also was 4 over 11. And we were again able to do that because of the division property. All right, so since I have these two sets of sides that have the same proportional value, the same similarity ratio, then I can say that those sides are also equal to each other because of the transitive property. So I have FR over FE is equal to FS over FD by the transitive property. You also could use substitution on that one. All right, then back into my image, I have that angle F is in both triangles. It's in both triangle SFR and in triangle DFE. So I'm going to say that angle F is congruent to itself. Angle F is congruent to angle F and is congruent to itself because of the reflexive property. And that allows us to say that I have two sets of corresponding sides that are congruent and proportional, and I have one shared angle between the two, and their corresponding angles are also congruent. So therefore I can say that triangle SFR is similar to triangle DFE by the side angle side triangle similarity theorem. All right, so that's our proof, and now that we've proven that, if we wanted to go back and solve for the only side length that we don't know, which is DE, then we could. And we would do that by setting up a proportion. So I'm actually going to walk through that. I realize it doesn't ask for it, but it's another good example to do this with. So I have a number of options here. I have DE as our missing side, and that I'm going to set to let's do this side. So DE to 88 is equal to 44 to 32. So I have 44 on top and 32 on the bottom. I'm going to do my cross products, multiply cross. So I have 32 times our unknown length of DE is equal to 88 times 44, and 88 times 44 is 3,872. Going to divide out 32 on both sides. And that leaves me with DE is equal to 121. So that is the length of DE. All right, so there's another example of when you can find that missing side. That is where we're going to stop for today. Again, if you want to see a full example video for examples 5 and 6, I will have those linked onto YouTube in the extra examples page. Otherwise, you can see the completed version in the notes key, which will be posted in the Drive folder attached to the Unit 8 module on Canvas. We will pick back up with Section 3, where we'll learn a few more theorems and how to use them to solve for missing side lengths with a similar triangle.